Hey, in this video we're going to talk about how we graph transformations of sine and cosine. We're going to cover horizontal translations or phase shifts and the vertical translations. Alright, the first thing that we're going to talk about are horizontal translations or phase shifts. These are just shifts left and right. So if you're just looking at an equation like this, you can guess that it's probably going to come from this c. And we know that because all other parent functions, whenever we add or subtract something to x, it shifts the graph left and right. Now, we have to notice that this is actually bx. So the phase shift comes from negative c over the absolute value of b. But it's actually easier if we think about it in a just slightly different way. We're used to seeing a minus sign right here because the shifts left and right usually go in the opposite way. That's intuitive. So I like to think about the functions like this. And if you notice here, in this version, the b is actually factored out. So let's look at a problem. We're going to graph y equals sine of 3x minus pi over 2. So the very first thing I want to do is factor out b. Remember, factoring out is just dividing through by that number. So now we have y equals sine of 3 times x minus pi over 6. Because pi over 2 divided by 3 is pi over 6. This means that the graph is shifted to the right by pi over 6. All right, so let's write out all of our key information. First of all, what's the amplitude? Remember, the amplitude is whatever's multiplying this sign. In this case, the amplitude is 1. The period comes from 2 pi over b, so this would be 2 pi over 3. And the key point increments, and the key word here is this increments, because no longer are we actually going to hit these points because of the phase shift. But the key point increments come from the period divided by 4. So this would be 2 pi over 3 over 4, which is 2 pi over 12, or pi over 6. And the whole graph was shifted to the right by pi over 6. So now we're ready to graph. Okay, so we know the basic shape of sine graph. We know that it's shifted. Let's start graphing this. It's shifted right by pi over 6. So the sine function usually starts at the origin, and now it's going to start at pi over 6. Because the period is 2 pi over 3, it would normally end here at 2 pi over 3, but instead we have to add pi over 6 plus 2 pi over 3, which is just pi over 6 plus 4 pi over 6, which is 5 pi over 6. That's going to give me my ending point of sine. We also know that this is just going to go up and down by 1. And so just to make this easier, I'm going to make this 1 and this negative 1. And now I just need the points in between. So the key increments are every pi over 6. So I'm going to take my starting point and keep adding pi over 6. So I've got my starting point, pi over 6, add pi over 6, that's 2 pi over 6, or just pi over 3. So I'm just going to graph at pi over 3, 1. Now I'm going to add another pi over 6. That puts me at 3 pi over 6, which is just pi over 2. So yeah, a lot of converting fractions. Plus another pi over 6 is 4 pi over 6, which is 2 pi over 3. And then finally, plus another pi over 6, that puts me at 5 pi over 6, which was my ending point. So now I've got one cycle of this sine function. And if I wanted to do 2 full cycles, I could continue. But that would be the function right there. And just to make it a little bit easier to see, you can see that we started at pi over 6, went to pi over 3, pi over 2, 2 pi over 3, and 5 pi over 6. All right, the last thing I want to talk about are the vertical shifts, and this just comes from this d right back here, just like all the other parent functions. All it does is shift the graph up or down, all right, creating a new horizontal axis called the sinusoidal axis, or the midline. So whereas sine of x, usually there's this line right through the middle of it. And for this, it's because we have plus 0. right? And so it's at 0. So sine of x plus 1 has a midline at 1. So now let's graph one more function where we include a vertical translation as well. So let's graph y equals 2 cosine of x minus pi plus 1. Notice that there is no b, so I'm not going to have to factor out a b or anything. But what are the transformations? So this has an amplitude of 2. Its period is 2 pi over b, which in this case is just 2 pi over 1, so 2 pi. The key point increments will come from 2 pi divided by 4, so every pi over 2. The phase shift is shifted right pi. And the midline was shifted up 1, so the midline will be at y equals 1. All right, so the very first thing that we want to graph is that midline. So I'm just going to use the scale that was set here. So the midline is 1. Now, with an amplitude of 2, its maximum height will be 3, and its minimum will be -1, because it'll go up and down 2 from the midline. This is a positive cosine graph. So remember, positive cosine graphs like start above and kind of dip like that. So with a shift of right pi, I'm going to start here at pi, and it's going to start above at pi 3. With a period equal to 2 pi, we're just going to add that to the pi. We know that this is going to end at 3 pi. So 3 pi 3. Now, just like last time, I'm going to take my starting point and just keep adding my increments of pi over 2. So it's easiest if I just put these in with the same denominator. This puts me at 3 pi over 2, so I'm going to hit my next key point. Plus pi over 2 would be 4 pi over 2, which is 2 pi. And you see I'm just hitting my highest and lowest points. Plus another pi over 2 would be 5 pi over 2. I'm back on my midline. Finally, it would be 6 pi over 2, which is 3 pi. So this cosine function looks something like this. All right, and that's all the horizontal and vertical translations of sine and cosine. Goodbye.